Hi, in today's module number 13, we are going to talk about incident preparation and investigation. Now, this concept of incident preparation and investigation is linked to digital forensics as well. So, we'll explore some of the fundamental concepts in business continuity planning. This is an area where the organizational resilience that ensures that the company can keep running and quickly resume the essential functions after disruption. It could be any sort of attacks, it could be network failure, it could be maybe the data exfiltration or anything. But we want to make sure that we are back in business as soon as something happens. So we need to have some planning for that. We'll be covering business impact analysis, continuity of operations, disaster recovery plan, and a single point of failure to better understand that how can we make sure that our organizations are up and running. So if we are talking about business continuity planning, we have these four topics which are very important, which is business impact analysis, continuity of operations, disaster recovery plan, and the single point of failure. So let's try to understand what is business impact analysis. It evaluates the potential effects of the interruptions to the critical business operations based on various disaster scenarios. Now, its components could be identification of critical processes, assessment of potential losses, or priority settings. So, in business impact analysis, it would help us in identify and evaluate the potential effects of an interruption to a critical business operations as a result of a disaster, an accident, or an emergency. The main goal of business impact analysis is to identify and find the operational and financial impacts that could be there because of any sort of disruptions. It involves defining the key services and products that are crucial for the organization's survival and determining the maximum acceptable downtime for those critical components. So the example could be a financial firm can conduct a BIA to determine that which of its services can be restored first to maintain the market operation. So you'll prioritize the things which are critical, you'll take them first, and then you'll make sure that those services are up so that at least you are able to perform the actions. Then we have business continuity operations, as the name suggests. We develop the procedures and instructions an organization must follow to continue and restore core operations during and after a disaster. So critical functions identification is important, resource allocation, and succession planning. So in COOP, which is continuity of operation planning, we'll focus on preparing an organization to continue its essential functions in the event of a widespread of emergencies or disasters, etc. So continuity of operations would aim to maintain the business functions or resume them quickly at an alternate location, just like we have Amazon Web Services and we have co-locations, a primary location and a secondary location from where, if in case the primary location is down, we'll be able to run the operations from the secondary location. It involves planning how to operate without certain resources, using interim measures, and even details of a temporary staffing solutions if they are required. So, example is a government agency can develop a continuity of operation plan to ensure that the essential services remains available during the severe weather conditions or events, etc. Then we have disaster recovery planning. In disaster recovery planning, we'll focus specifically on the recovery of information, technology assets, applications, and facilities after the disaster. So IT recovery strategies are there, data backup should be there, and recovery site arrangement should be there. So in a disaster recovery plan, it's a documented, structured approach that describes how an organization can quickly resume the work after an unplanned incident takes place. It is a comprehensive statement which consists of actions to be taken before, during, and after the disaster. The plan is to include and maintain the redundant systems and backups and outline how the IT operations will be back online in the shortest possible time. So if we'll take an example of an IT company, it has a disaster recovery plan that includes offsite backups and contracts with the cloud service providers to have an immediate failover in case your main systems would stop working. Then we have a single point of failure. It involves identifying any single components whose failure could result in a failure of the entire system. It's a risk assessment, and then we have system analysis and mitigation strategies. So in single point of failure, organization involved determining specific components where the failure could cause the system or the service disruptions. This process is crucial because it helps the organization to understand the vulnerabilities within their infrastructure and to develop strategies to maintain or to mitigate these risks. Now, the identification leads to greater system resilience and is a proactive measure to protect or to safeguard against any sort of potential failures. Example could be during the risk audit and manufacturing plant identifies that only there is a production line, identifies that if only production line is a single point of failure, they won't be able to perform the operations after that. After business continuity planning, we have building resilience and redundancy, in that we have high availability, RAID configurations, etc., which are there usually in the hard drives, and the power solutions and data storage and recovery plans. So let's try to understand what is building resilience and redundancy is. So if we'll talk about it, we'll explore that how organizations can build resilience and redundancy into their IT systems. It is also crucial because it ensures that the services can remain available and data remains intact even in case or in a situation where we have hardware failures, any sort of natural disasters, or other disruptive events, etc. So first of all, we have high availability. We call it as HA servers as well. These are the system designed to operate continuously without failure for a longer duration of time, utilizing the techniques like clustering, etc. The server clustering, failover mechanisms, and load balancing, etc. are the examples of it. High availability servers are designed to minimize the downtime to ensure that the services are continuously operational. This is achieved through various technologies and architectures such as clustering or failovers, etc. In a cluster, multiple servers are linked together, and if one fails, another one would take over its load almost instantaneously, that you won't even feel that there was an interruption. This setup is crucial for critical applications where even a short period of downtime can cause the significant operational disruptions or financial losses. So in a practical lifetime example, like first we are giving a cloud service provider would use clustering for automatic failover to ensure the hosting services are available 24/7. You might have seen that we have Active Directories, which is usually we maintain Active Directory 1 and 2, that in case if one fails, your users can still authenticate themselves using the Active Directory too. Same goes for the firewalls that we have. We have multiple firewalls in place. So if it's one stops working, the other one would take over. And in case if we need to update one firewall and it requires a restart, which would take some time, so the other firewall would take over. In the meantime, the primary firewall is back. Then we have RAID solutions. It's a data storage visualization technology that combines multiple physical disk drives components into one, more logical units for redundancy and performance. So we have RAID level 0, 1, 5, and 10. 0 is usually stripping, or in 1 we have mirroring, like both hard drives would have the same data. So if one hard drive fails, the other mirroring drive would be there, so it would start performing through that. In the meantime, you can remove the faulty one and replace it, so it would rebuild the hard drive to have the mirroring back on the new hard drive. In RAID, it's striped with parity, and RAID level 10, it's striped with mirrors. So you need to understand RAID configurations in detail in IT infrastructures. When you are configuring the servers, you must have a clear idea of a redundant array of independent disks, which is a data storage visualization technology that combines multiple physical disk drives components into one or more logical units. The purpose of a RAID is to enhance the data redundancy and to improve the overall performance. Different RAID levels offer various balances, performance, data availability, storage capacity, etc. For example, as said, RAID level 1 mirrors the data across the disk. RAID level 5 would distribute the data across 3 or more disks with a parity and recovery. And RAID level 6 extends the RAID level 5 by adding an additional parity block, thus allowing the two disks to fail simultaneously without any data lose, or you'll not lose anything on that. Financial institution would have RAID level 5 in its database servers to ensure that the data integrity and speed is always there. So even if there is a failure, it would be able to recover itself automatically. Then we have power solutions. We usually call them as UPS, or the system designed to provide uninterrupted power supply to prevent the data loss and maintain the operations. Offline UPS should be there. It has batteries, and UPS provided a constant power. We have different power solutions for that. That's for shortage period of time. You might have seen the UPS from different companies. But if the outage is for a longer period of time, sometimes we need to have the maybe diesel powered generators which can feed the power to the data centers. So it ensures continuous power supply to critical systems, maintaining the high availability. UPS and backup generators are common solutions that provide the emergency power to a system when the main power source fails. Now, UPS systems can also help in mitigating the power fluctuations, such as the surge protection or the brownouts, which can damage the equipment and can lead to data loss. The redundancy is essential not only to data centers, but for any businesses where the system availability is closely tied to the operational processes, etc. So it should be your responsibility to keep an eye that if you're using a UPS and you are using it for a longer period of time, if its batteries requires replacement, you should replace them on regular intervals. So example is data center implements the online UPS system to protect the sensitive equipment from the power surges and to provide the power continuity. Then we have data storage and recovery technique, a technology used to store the data securely and to recover it from the loss in case of an incident. So we have recovery point objective, recovery time objective, backup, replication, snapshots, etc., and journaling. So effective data storage and recovery solutions are the fundamental to resilience and redundancy. Beyond RAID configurations, organizations implement robust backup solutions that involve regular snapshots of data being stored on offsite, maybe in the cloud. This would ensure that in an event of a physical disaster like a fire or a flood or any disaster like that, data can still be recovered from another location. Furthermore, implementing a well-planned disaster recovery strategy ensures that the data can be quickly restored and systems can be brought back to normal or online in a minimum downtime. For example, an e-commerce company can implement hourly data snapshots for an offsite replication to minimize the data loss in case of a server crash, etc. Now we have, just like other things, we have site and network resilience. In that we have SAN, multipath and network redundancy. Then we have site for business continuity and cloud solutions. So if we look at the SAN, multipath and network storage, it says that these are critical for managing the large volumes of data. SAN multipath is a method used to provide multiple physical paths between the server and the storage system. This setup increases the availability and the fault tolerance of storage resources by ensuring that if one path fails due to the hardware failure or network issues, data can still be accessed through another path. Alongside, network redundancy is achieved by implementing multiple network paths for the backup connections, etc. This redundancy is critical for ensuring that the network communication remain uninterrupted even if one path of the network fails, thereby enhancing the overall network reliability and performance. So its components could be the SAN network multipath, network failover solutions, and the load balancers. Example could be a corporate data center can use the SAN multipath to ensure the continuity of data availability even if one storage path would fail. Then we have site for business continuity. It means that having multiple geographical sites for business operations in a strategic business to business continuity. By distributing the data centers and operational sites across different locations, organization can reduce the risk of a single event like a natural disaster or a power outage, etc., impacting all critical functions. So each site can act as a backup for another, enabling the seamless failover in case if one side goes down, the other one would take over. This geographical distribution is critical for large organizations that require high availability and minimal downtime to maintain the operation and services. So we can have a hot site, we can have a cold site, and we can have a warm site. So a hot site could be fully equipment thing where everything would be operational. Cold site would be infrastructure would be there without having any active resources. And warm site is partially the equipment should be there, but you need to restore the backups to run the services. So a company can maintain a hot site in a geographical distant region to immediately take over operations if the main data center encounters a disaster or anything. But keep in mind that if you are having a hot site, it requires a lot of operational cost which would be associated with that, just to make sure that your hot site would have all the backups which are there at the main data center as well. Then we have cloud solutions. They play a pivotal role in enhancing the site and network resilience. By leveraging the cloud infrastructure, organizations can benefit from built-in redundancy, high availability, and disaster recovery capabilities without the need of substantial upfront investment in physical hardware. Cloud providers typically operate multiple data centers in various locations, offering redundancy, data mirroring services, etc., that can help you ensure the data integrity and accessibility. Furthermore, cloud environment can be scaled rapidly to handle the additional load in one site experience if one site would experience an increased demand or if the other sites are compromised. So it would be a utilization of cloud services based on the higher level and data protection, etc. So the cloud storage would compute and provide the services like that. Hybrid cloud environments are more flexible, and then we have cloud disaster recovery as well. So an online retailer leverages the cloud services for real-time data replication, which uses a cloud data recovery capabilities to ensure the minimum downtime. Then we have incident investigation technique, which is very important if you are dealing in any organization where there are constant attacks coming to your systems, making sure that your business is up and running. So you must understand the incident investigation techniques, etc. How can you deal with that and to make sure that your services are up and running? In that, first of all, we have root cause analysis. It's a methodological approach which is used to identify the underlying reasons why an incident occurred. In the context of cybersecurity, RCA helps in determining what went wrong in the system, the process, and the behavior that allowed the breach of the failure or any incident which took place in your organization. This technique involves gathering the data, analyzing it to trace the sequence of the events that led to the incident, and identifying both the immediate cause and the deeper systematic issues, etc., which were there. The main goal of this one is to prevent the future incident by addressing these root causes rather than just the symptoms of it. So the components could be step-by-step analysis, cause and effect diagram should be there, and 5 whys, that why it happened, where it happened, who did it, and all those things. Now the example could be a data breach in an IT security team. RCA would determine the inadequate access controls, for example, or the primary cause of it, that what led to that thing. Now we have data sources for investigation, various tools, records used to determine the information using the incident investigation. So effective incident investigation would rely heavily on the quality and comprehensiveness of the data gathering. We could have log files, we could have the network traffic audit logs, we can even have the user reports, which would help us in finding all that information. Then vulnerability scans could be there. Your SIEM dashboards can give you information that what happened, or the packet capture. You can see that if there are any rogue sources which are constantly updating data somewhere, that would give you an idea about what happened actually. So a security analyst can review the firewall logs, SIEM dashboard alerts to trace the paths of an attacker through the network, etc. Then we have digital forensics and e-discovery, which is very important to practice of collecting and analyzing the electronically stored information that would be legally admissible as well. So you'll collect the evidence in a way which you can present in front of the court as well. That would involve data imaging, forensics tools, etc., chain of custody. We have lots of tools for digital forensics analysis that we have covered. You can go and see the practical demonstration of the investigations, how they are conducted, and which tools do we use actually in order to conduct the analysis. So the digital forensics would involve the scientific examination and analysis of the data on the retrieved computers or the storage media, such as the information which is stored or used or which was even deleted from the hard drives, which with the help of which we'll come up with the evidence which we can show in the court. Now this discipline requires a meticulous approach to preserve the integrity of the data and the metadata to maintain its admissibility in the legal proceedings. Now, e-discoveries, the electronic discovery, refers to the process in which the electronic data is sought, located, stored, and searched within the content using the evidence in a civil or criminal legal cases. E-discovery process must be ensured that the handling of the data complies with the legal standards to avoid any problems later that you mishandled the data or anything like that. So during the investigation, the unauthorized data access forensics tools can be used for the hard drives, for the data which was deleted, etc., which could be used for the evidence purposes, etc. Now we have digital forensics and the procedures which are there. Now there is a process which we need to follow in order to investigate the things whenever if we have an incident and we need to find out that what went wrong. So digital forensics is a critical aspect of cybersecurity, crucial for investigating the breaches, solving cyber crimes, and understanding how attacks were actually taken place, or the tools that they use in order to penetrate in your network. So there would be lots of steps which would be involved in the digital forensics investigation, like secure the scene, preserve the evidence, document a chain of custody, examine for the evidence, generate reports, and examples of forensics data. So let's try to see it one by one. Secure the scenes means the initial step to prevent any further alteration or loss of the data, ensuring that the digital environment is preserved. Isolate the affected system to prevent the data tampering and losses. So that's the first step in digital forensics, in which we'll investigate and we'll try to secure the scene. This means that we'll ensure that no unauthorized person can access the area where the incident occurred, including the computers, networks, or any other devices. This is critical to prevent the tampering or the alteration of the evidence in a digital context. This might involve isolating the affected parts of the network and disabling the remote access systems, etc. So we usually create a copy, which is a DD image of the actual hard drive, etc., just to make sure that we will be investigating the DD image, but we will not touch the actual file or the actual system which was there, because the DD image will have the detailed image of all the things which were there on the system. That's what we are talking about, preserve the evidence. Technique used to maintain the integrity of the digital evidence in form of the time of the discovery through analysis, creating a bitwise copy storage services using the write blockers, etc., so that even during the investigation phase, there is nothing written on the hard drive which would affect the actual hard drive which was compromised, or the USB, or the data which was there on those systems. So once the scene is secure, the next step is to preserve the evidence, involving making the exact copies, also known as the forensics images, of all the storage devices by capturing the memory data from running computers and servers. It's important step to be done in a way that it doesn't alter the data, using the write blockers or the forensics tools, with the help of which we'll create a bit by bit copy without modifying the original source of it. So forensics analysis, we'll create an image of the affected drives using the FTK imager, which would preserve the data state in a DD or FTK format. Then we have document chain of custody. That's a document which would track the handling of the storage and the transfer of digital evidence to establish its authenticity and integrity. So we'll have to maintain a record of everyone who accessed the evidence, including the timestamps and the purpose of the access. So it's a document with a chain of custody, which is essential in maintaining the integrity. It's a process of involving keeping the detailed records of who collected the evidence, when it was collected, how it was collected, where it was stored, and to whom it was transferred, etc. This document is crucial for establishing the authenticity, integrity, and the evidence, especially if it is presented in court, etc. So, a log is kept with the details of each person who handled the digital evidence in time and access, etc. Then we'll examine for evidence and generate reports, which would include the conducting a thorough analysis of the preserved data to uncover the evidence, and then document the findings in the detailed reports, etc. So if we'll examine it, the examples of the evidence could be the system logs, emails, document files, browser histories, or any deleted files which could be there. So the examination phase would involve analyzing the copies of the data with various forensics tools that would uncover the relevant information, clues about the incident when it was occurred. This might include recovering the deleted files, examining the logs, tracing the user activities, etc. After examining and detailed analysis of the report, we'll generate an outline of the findings, the relevance of the evidence with the case, or any expert interpretations which could be there in conclusions drawn from the data that we'll collect. So the tools that can be used for that could be NCASE or Autopsy. Detailed video on Autopsy is also there on our channel to examine the file system recovery for the deleted emails and to trace the user logins, etc. Now we have different examples which could be there for data forensics analysis. For example, the CPU, RAM, hard disk drive, and the temporary file system storage and the logs which are there. We'll analyze the RAM dumps to retrieve the data which was there in the memory before the system crashes, and the analyzing the network logs, which would give us a lot of information about what took place on your network. So that was our lecture on incident preparation and investigations.